GCSE Geography revision with Miss Heard. Weather hazards. What is global atmospheric circulation? Global atmospheric circulation helps to explain the location of the world's climate zones and the distribution of weather hazards. The atmosphere, the air above our heads, is a highly complex swirling mass of gases, liquids and solids. These include water droplets, water vapour, ash, carbon dioxide and oxygen. How does global atmospheric circulation work? This involves a number of circular air movements called cells. These cells all join together to form the overall circulation of the Earth's atmosphere. Air that is sinking towards the ground forms areas of high pressure. For example, at the North Pole, winds on the ground move outwards from these areas. Air that is rising from the ground forms areas of low pressure, for example at the equator. Winds on the ground move towards these areas of low pressure. Winds on the ground are distorted by the Earth's rotation. They curve as they move from areas of high pressure to areas of low pressure. Surface winds are very important in transferring heat and moisture from one place to another. The patterns of pressure belts and winds are affected by seasonal changes. The tilt and rotation of the Earth causes relative changes in the position of the sun overhead. These seasonal changes cause pressure belts and winds to move north during our summer and then south during our winter. The most important influence on worldwide variations in climate is latitude. Because of the curved surface of the Earth, the equator receives much higher insolation than the polar latitudes. Parallel rays of the sun are spread thinly when they strike the Earth's surface at high latitudes, whereas at low latitudes, such as the equator, sunlight is much more concentrated. As a result, air at the equator is heated strongly. It becomes less dense and rises to a high altitude. This creates a global climate zone of low pressure, the equatorial zone. After rising, the air spreads out and begins to flow towards the north and south poles. Meanwhile, the low insolation received at polar latitudes results in cooler, dense air and high pressure. As the air sinks towards the ground level, it spreads out and floats towards the equator. Taken together, the low pressure belt at the equator and the high pressure belt at the poles provide the basis for a simple convection cell to operate. Global atmospheric circulation, however, is a little bit more complex. 3 convection cells operate, not just one. As well as pressure belts at the poles, there are areas of high pressure at the tropics of Cancer and Capricorn. Air sinks towards the ground there. As it descends, the air warms. The result is high pressure and hot, dry desert conditions. The circulation of air between the tropics and the equator is called the Hadley cell. Global circulation involves 3 cells because the Earth rotates on its axes. The movement generates strong, high-altitude winds, which wrap around the planet like belts. These winds flow towards the east as the Earth spins and interact with the convection cells. A particularly strong high-altitude current is called a jet stream. The exact position of the jet stream and convection cells varies seasonally. Seasons arise because of the Earth is tilted on an axis. Each year, as the planet journeys around the Sun, insolation rises and falls at each latitude. In high polar latitudes, the Sun does not even rise during the winter. In southern Europe, temperatures rise steeply in the summer before falling in winter. How does global circulation affect the world's weather? Global atmospheric circulation is what drives the world's weather. The circulation cells, pressure belts and surface winds affect the weather around the world. For example, the trade winds in the tropics are responsible for driving tropical storms, hurricanes, across these regions, bringing chaos and destruction to coastal regions in their path. How do global pressure and surface winds influence precipitation? Global pressure and surface wind patterns influence precipitation in several ways. Rainfall is high and constant throughout the year near the equator. As hot air rises, it cools slightly. Water vapour is converted into droplets of convectional rainfall. The low pressure zone around the equator is called the Intertropical Convergence Zone, or ITCZ for short. Air rises and triggers bursts of torrential rain. Tropical storms develop along these waves. Once they gain energy, they can travel even further away from the equator. Rainfall is often higher in coastal areas in Western Europe due to the movement of the jet stream over the Atlantic. Rain-bearing weather systems called depressions, also known as cyclones, follow the jet stream, often bringing stormy conditions to the UK's west coast. Rainfall is often low around the tropics of Capricorn and Cancer. Dry air descends there as part of the Hadley cell, resulting in arid conditions. Precipitation is also very low in polar regions and falls mostly as snow. The cold air has a limited ability to hold water vapour. This concludes Miss Heard's revision on global atmospheric circulation.